have 3 examples that I want to go over with you guys. Please pause the video and get your paper, pen, and calculator. Let's get started. I'm going to go over 3 examples in finding the missing side length of these similar right triangles. Highlight the parts that are labeled. In this case, I have the hypotenuse and the short leg of triangle 3. Now, the chart is optional. If you are comfortable setting up your proportion and solve for the variable x, you could go ahead and do that. But I prefer using the chart so you could easily set up the proportion that I need in solving for the variable. So let's go ahead and fill in the table. Triangle 3, the short leg is 9 and the hypotenuse is 15. While this triangle, which is triangle 1, has hypotenuse of x and a long leg of 15. So I'm going to go ahead and write those down on my chart. Now, when you're setting up your proportion, you may compare the parts of one triangle equals the same parts of another triangle. So I will be comparing short leg to hypotenuse. Since I'm comparing short leg to the hypotenuse on the left ratio, I'm going to do the same thing on my right ratio. So I'll end up with 15 over x is the same as 9 over 15. Applying cross product rule, I have 9x is the same as 15 times 15, which is 225. And I'm going to divide that by 9. The value of x would be 25. Now, if you would like to set up your proportion by comparing corresponding sides, meaning short leg to short leg from triangles 1 to 3, and hypotenuse to hypotenuse from the same triangles 1 and 3, that's perfectly fine. So let's go ahead and set up the ratio. 15 over 9 is the same as x over 15. Now, applying the cross product rule, you will end up with the same answer. So either way, whatever you're comfortable using in setting up your proportion, that's perfectly fine. Let's take a look at example number 2. Let me scroll this up. So the first thing I'm going to do, now again, the chart is optional. I prefer using it because it make it easier for me to set up a proportion. So my triangle 3 has a short leg of 36 and a long leg of x. So I'm going to write those information on my chart. The other triangle I have is this short leg of x, and this is my the long leg of triangle 2. So short leg of x, and I don't know what the long leg of triangle 2, but the length of this side I know, which is 100, and the length of this side is 36. Now I'm looking for this. So to find that, I'm just gonna subtract 136. So that gives me 64. So the long leg of triangle 2 is in fact 64. Now, in setting up my proportion, again, I'm gonna compare short leg to long leg of triangle 2. Since I'm comparing those two parts of triangle 2, I'm gonna follow the same comparison on triangle 3. And I'll end up with x over 64 is the same as 36 over x. Now applying cross product rule, I have x times x is x squared, and the product of 36 and 64 is going to be 36 times 64 is 2,304. Now to undo squaring, I'm going to extract the square root of 2,304. Which is 48. So therefore, the value of x is 48. Let's take a look at example number 3. I'm going to highlight the long leg of triangle 1, which is 7 times the square root of 33, and the hypotenuse is x. So let me go ahead and write those down. Hypotenuse of x, long leg is 7 root 33. While the long leg of triangle 2 is 33, and the hypotenuse is 7 root 33. 7 times root 33. Now this time, let's set up our proportion by comparing long leg to long leg from triangle 1 to triangle 2, and hypotenuse to hypotenuse from triangle 1 to triangle 2. So I have 7 times root 33 over 33. Again, I'm comparing long leg to long leg, their corresponding sides of triangle 1 and triangle 2. My right ratio would be x over 7 root 33. And I'm comparing hypotenuse to hypotenuse from triangle 1 to triangle 2. Now applying cross product rule, I'll have 33x is the same as the product of 7 root 33 times 7 root 33. Let me just zoom this in so you could see it. Now to simplify the right side of this equation, I could rewrite the two factors and separate them into 4 factors. 7 times 7 times root 33 times root 33, which is equal to 7 times 7 is 49. Root 33 times root 33 is simply 33. Okay, so I'm keeping 33x on the left side of the equation and dividing each side by 33. 33 get cancelled, so therefore x is equal to 49. Now if you would like to verify the product of 7 root 33 and 7 root 33, you may use your graphing calculator. So let's go ahead and do that. 7 times root 33 times 7 root 33 is equal to 1617, and divide that by 33 will give you 49. So our answer is correct.